What's up, pre-calculus students? Mr. Messner from his classroom, not at home. So I'll be doing all the videos. So there you go. LT Lacrosse is in the background. I don't think you can see it over there. There you go. Wrapping LT Lacrosse here. Here comes the homework. So bunch of things, bunch of properties we learned about during class today. Change of bases, how logarithms, since they're inverses of exponents, they kind of work like exponents for all these properties. We will then use the properties to solve some equations, which is kind of like our ultimate goal, is like solving equations that have logarithms in it. The properties, just kind of practicing them so that we know how to use them. The first thing we learned about is the change of base formula, which is like log of, A of B if we're trying to evaluate that. This was really important before like calculators had log with different base buttons. It used to just have log base 10 in it. So you always use the change of base to get your calculator to give you the answer. And it's that you can have the log of like any number. I think I saw Miss Holder use a star here. I like that. So the log star of B divided by the log of that same number, that star of A. And that's the change of base formula. I forgot how this was derived. I'm sure I can get it somehow, but I don't want to spend time on it. But that's just like, maybe in my class, I'll teach how it's derived. But that's all it is. So it's like express log base 5 of 16 using base 7. So it's like log base 5 of 16. 7 is the star here. So we got log base 7 of 16 over log base 7 of 5. This is B, this is A. And we just do it over and over. Common log, this is maybe a question. Common log is base 10. Base 10. Remember that you don't have to write log base 10 like this. You could just use log. So and this is how people used to evaluate, this in a calculator. And I think I'm going to show you right now. It's not time to show you. They used to say you got to type in log 47, log 4. So ready? Log, so like 4 to what power is 47 is the question, right? Let's see, 4 squared is 16, 4 cubed is 64. It's something between 2 and 3. You got this log base in math, it's A. And this is how you can type it in as it looks. Back in the day, calculators didn't have this. So you see it's between 2 and 3, 2.777. So 4 to the 2.777 blah, blah, blah power is going to be 47. Back in the day, you just had this log button and this ln button. So you'd either type in log 47 divided by log 4, get the same number, or you did ln 47 over ln 4. Anyways. Natural log, okay? So log base 3 of 14. Again, log base E is the natural log. You use natural log ln like that. So ln 14 over ln 3. Base 2, ln x. Okay, so again, ln is log base E. We usually don't write something that's an ln as something else, but whatever, let's do it. So log base E. So x is like the B, E is the A, base 2 is the star, 2x, log base 2E. Okay, using the natural log, so this is log base 10 of 11. Using the natural log, that's log base E. E is the star, ln is kind of like our star, 11 over ln 10. Natural log, this is log base 10. It's not shown. You don't have a number here. You assume it's a 10. That's natural log 11 over natural log 10. All right, now we get into exponent properties and logarithmic properties, which are similar to exponent properties. Your teacher's doing a good job of showing you this, like the x squared times x cubed is x to the 2 plus 3. That's why we say that like the log of two numbers being multiplied, let's just say x or y, is equal to the log of x plus the log of y. We are going to start here, separate it out into this. Other properties, power to a power, x squared cubed is x to the 6. You multiply those powers together. Well, this is why if we have something to a power inside of a logarithm, we end up being able to take that 2 and move it down and kind of have the things being multiplied. See how they're like power to a power, we multiply. Here's like our power to a power, and then you can bring that 2 down, and that's the multiplied powers. The next thing is very similar to this, is like the minus. If I have like x cubed over x squared, we subtract it, like x to the 3 minus 2. Well, this is why if I'll have like log of things that are being divided, x and y, it's like I'll be able to subtract them, log x minus log y. Okay, so that's a reminder of all of them. Then there's the inverse properties, which is kind of how I teach things. So it's not something to like go over. It's like logs and numbers to powers undo each other. So if you're asked to expand, it just means like take this, use a property so it's not just things inside of parentheses. There's only one thing inside of each parenthesis. So here we have multiplication. The multiplication turns into addition. It's this property. So I got log base 5 of 25 plus log base 5 of x. My cursor just paused. Sometimes it happens. It'll come back. There it is. Log base 5 of x. We actually can do this, log base 5 of 25. Again, like how do you do it? If you have a calculator, you can do it. You can use the change of base. We're better than that though. Take 5 to the power, 5 to the power. You get 25 equals 5 to what number? That's 2. So this is 2 plus log base 5 of x. Okay. Log of 4 times x squared. So this is 4 times x squared, not 4x quantity squared. That's important. That 4 is separate from the square. Okay. So I'm going to separate this using our first property, log of x times y. So I got natural log of 4 plus the natural log of x squared. And then I'm going to use my power to power property so that I turn this into 2 natural log of x. It's very important to understand that like you can't add these things together. If I had like a number ln 4 times 2, it's not that you're multiplying the 4 by the 2. It's just kind of how like if I have a number in front of like sine x or like sine of a half, you don't multiply the 3 by the 1/2. It's like this is a function. This is not log of 8. A lot of students make that mistake. It's actually the log of 16. Ln of 4 squared can be written. And we'll do that in the next part of things. All right. Now we got division. Division works like the subtraction. So I got log x minus log 2. It's 10 to what power is 2? I don't know what that is, so I can't simplify that. Here, ln 3 minus ln z cubed. Well, that cube, I can use this power to a power property to write this as 3 ln z. And this would be like what we'd consider the completely expanded version. All right, we got multiple things going on. What I like to do is worry about the subtraction first, like the division, making sure I'm taking care of order of operations, which is like very important for this. I'll show you why when we get to that. But I like to first keep the 3y together. Then I have the x to the 4th being subtracted. This is the division of the two. Then I'll separate this 3x using this summation. Adding is like, or multiplying is like adding. Same thing here. Log base 2 of 3 plus log base 2 of y. 2 to what power is 3? I don't know, so don't worry about that. And then over here, the 4 gets brought down. That's the whole power to power property. So 4 log base 2 of x. And this would be fully expanded. Now, why I did not just do it all at once is for this reason. Watch if I do this all at once, okay? maybe I'm like, listen, this is boring. I'm just going to quickly do it. Log A plus log B minus, okay, now I'm dividing log C, and I guess that's multiplying log D. Okay, this is wrong. Why is this wrong? Well, watch how I can show you that this is wrong, where I just have one minus sign. Hopefully you guys figure out why. If, just worry about the division first. And I just say, okay, let's keep AB together minus, let's keep CD together. And this is like, you might do this correctly and still get it wrong because of an error in the next step. A plus B, okay, we can split that, A times B. We can split that into addition. Log A plus log B minus, we are subtracting this entire log C D, which means when we subtract the expanded form, log C plus log D, it needs to be in parentheses so that we realize we are dividing by C and we're dividing by D. We need to have that minus sign distributed to both. Okay, that would be correct. This form, notice minus and minus, or minus parentheses. Condense. Okay, now we're going the opposite way. Okay, so we keep these rules in our pocket. We're ready to pull them out, and now we can go from there. This helps us sometimes if like we don't have the access to a calculator and we're trying to figure out what this number is. Sometimes when you simplify the things, you get the log base of something to something else is something that you can find. So subtraction, same as division, log base 8 of 54 over 2. What's 54 divided by 2? That is 27. Eight to what power is 27? So I can't simplify this anymore and get a number. But sometimes you can. Natural log x plus natural log x plus 3. Well, it's addition, so we can make this multiplication. Natural log x times x plus 3. Maybe it'll be beneficial to distribute things. Okay. Now you might be thinking, oh, that 2, I could bring that 2 down. No, you can't. Because of its x squared plus 3x, because of this plus 3x, it's not like both of these things. It's not like x plus 3 being squared. That, you could bring that in front of a log, but since it's just one thing, no, just leave it where it is. There's nothing to simplify here. All right, but now we do have some numbers in front of logs, so we can move them. It's the whole power to a power property with exponents. Similar in logs. Here's my power to a power. Here's the multiplication of the powers. I'm going to do the powers first, and then I'm going to combine the logs, multiplying. Oh, this was fun. Can I simplify 8 to the power 27? 27 is 3 cubed. It is not a version of 8. Anyways, like back in the day, like you'd have to know how to do this to sometimes get like answers that were whole numbers because you didn't have a calculator. All right, fun. I'll worry about this first. Natural log, I got 25z squared. This entire thing is to the 1/2 power. It's very important that we know that it's that entire thing. It's not just the z squared. It's the entire thing, and that's going to be important when we start simplifying. So you got to remember, if you have like multiple things taken to a power xy squared, it's not just x times y squared, it's x squared y squared. This power gets multiplied into both. It's xy times xy. So if you have something like 4x squared, that's 4 squared x squared, that's 16x squared. If I have a 1/2 power, a 1/2 power is the same as a square root. So if this was like 4x squared to the 1/2, I would take the square root of 4 and the square root of x squared. Now, x squared to the 1/2, power to a power, multiply the powers. It's just like logarithms. 4 to the 1/2 is 2. So that is what we're doing here. I got 25 to the 1/2. That's the square root of 25. That's 5. I got z squared to the 1/2. 2 times 1/2 is just 1. So I got natural log of 5z. And over here I have minus log base 8 of y to the 7th. I think the reason why we put this here is that we have different bases. When you have different bases, you can't combine them. It's similar to how, like, if I have different exponents, x squared, y cubed, you don't say this is like xy to the 5th. That's not right. If I have different bases, you can't apply your properties. Now, there is going to be a question in the future where we will have different bases, but I can rewrite it so that it does have the same base. It's tricky. It took me a while to figure it out when I saw it. It'll probably take me a while this time too. So don't do anything here. You just leave this like this. All right, let's just kind of power through here, unless I see something crazy. I'm going to move the 2 up, move the 3 up. Going to add, which is multiply. So log base 8 of, this is a good question. Doesn't matter. The x gets multiplied by the y squared, and then I'm going to divide by the z cubed. If you did this in any order, if you did like the y squared divided by z cubed and then multiplied by the x, you'd have x times y squared over z cubed. Doesn't matter. What you don't want to do is take the x. It ends up working out, actually. It works out in any order, plus a negative. That's another way to kind of figure out that minus is the same as like dividing. If you have like minus log of something, you can make this a -1 plus a negative. Put that over here. You got log x to the negative first. That turns into log of 1 over x. So that's like the dividing. All right. I keep digressing. You guys just put the answers. Log base 3, this is x cubed. Move the 3 up. I'm going to leave the minus there. I could make it a -4 if I wanted to. Log base 3 of y to the 4th. Could make this a -4 if I wanted to. And then that shows me it's like 1 over, and then I multiply things together. Log base 3 of z to the 4th. So I got log base 3. I got x cubed that's going to be on the top. I'm going to be dividing by y to the 4th and dividing by z to the 4th. Maybe it helps me to show, like, if this was a -4 and this is a -4, this is a -4, that these can be turned into 1 over y to the 4th. This is 1 over z to the 4th. And then if you're adding these 3 things together, it's x cubed times 1 over y to the 4th times 1 over z to the 4th. You just end up with the y to the 4th and the z to the 4th in the denominator. So, like, it's not like x cubed divided by this, which you can do. That's correct, but it's not as nice as this. But probably not necessary. Just leave the 4, leave the minus signs, just subtract means divide. Okay, let's look at this. So I got this log x minus, I'm going to combine this x plus 1 times this x minus 1. So this log x plus 1, x minus 1. This is like in its own set of parentheses. X plus 1 times x minus 1, right? Distribute everything. X times x is x squared. X times -1 is -1x. 1 times x is x. The -1x plus the 1x go away. 1 times -1 is -1. So I get log x squared minus 1 as being subtracted from the log of x. Subtraction is like dividing the 2, x over x squared minus 1. How many of you out there really want to do this? How many of you want to do that? Yeah, you? I bet you a lot of you. Hey, do you want to do that? You want to say it's 1 over x minus 1? No, no, no. It's like such a common mistake in all math. It's not. You can't simplify this because of the subtraction. Addition and subtraction are simplification's enemy, okay? Let me show you an example. Let's use 3. 3 over 3 squared minus 1. Let me just evaluate this really quickly. If I were to not simplify anything, I'd get 3 over 8, 3/8, okay? Now let's say you math student think, oh, whenever I see something that looks the same, I can simplify, and you cross this off and you cross this off, and you're like, oh, x over x squared minus 1 is the same as 1 over x minus 1. Well, then that means you're telling me that 3 over 3 squared minus 1 is the same as 1 over 3 minus 1, or 1/2. Is 3/8 the same as 1/2? No. So you can't do that. I always show my students like numerical examples of like when simplification fails. So like it's not true. You can't cancel because of the subtraction. Leave it like this. 4, natural log x plus 5 minus 2. Okay, I'm going to just worry about the stuff inside the parentheses. It's like whole order of operations first. So x times x plus 5. And then the 2 comes up here, but it's minusing. Maybe I put it as a -2, so I have 1 over. But I'm just going to keep it as a 2 right there. Ooh. I'm going to put that 4 up above things, but I'm not going to distribute. Maybe I will, maybe I won't. But it's this entire thing that is going to be taken to the 4th power. So like parentheses to the 4th power. If I were to distribute, I would distribute to the x, and I'd distribute to the x plus 5. I would not distribute individually to that x and that 5 because of the plus. Just like how you know like x plus 2 squared is not x squared plus 4. You don't just distribute it in because of the plus. Addition, the enemy of simplification. So let's just like leave it like that for now, and let's see if like I can simplify it later. I put that 2 up. I'm subtracting these 2. I kind of just want to divide right now. If this was like a -5, I'd be able to cancel some things, which would have been nice, but it's not. So I am going to distribute this, I guess. This is x to the 4th. This is x plus 5 to the 4th. This would be divided by x minus 5 squared. This one's a little bit like messy and like, what's the final answer? Is this the final answer? Is something else the final answer? Do you want me to distribute this? A lot of you guys are never comfortable leaving like x minus 5 squared. You want to like multiply everything out. Don't stress about these for like quizzes or tests. Like we'll tell you where to stop. I'm telling you where to stop. All right, here's the challenge. They got different bases, but we are told we can write them as a single logarithm. How? Like, again, I told you, you can't apply these properties unless the logs are the same. Well, I'm going to try to turn this log base 16 into a log base 4. And this is how I kind of worked through it earlier when I was just glancing through this. I started with just like, what is log base 16 of y? It's x. I'm just going to say log base 16 of y is x. And I'm going to take 16 to the power of both sides, and I'm like, let's get rid of this logarithm. We're not comfortable with logarithms that much. I'm more comfortable with exponents. So 16 to the power of both sides, I get y equals 16 to the x. And then I think to myself, I want a 4 here. I don't really want this 16. I want a 4. Well, I know that 16 right here is the same as 4 squared. So I'm going to take this 4 squared, and instead of having 16, I'm just going to write 4 squared. 4 squared is the same as 16. All right, so that's the first thing. Next thing I'm going to do is write this power to a power as a product. Like the 2 and the x can be multiplied together, giving me 4 to the 2x. Okay, great. Got that. The next thing I'm going to do is go back and rewrite this as a log base 4. How do I do that? Well, it's like 4 to the power. The 4 is the important number. Take log base 4 of both sides. If I take log base 4 of both sides, I get now log base 4 of y is the same as 2x. Okay, well, I already told you that x was log base 16 of y. Well, 2x is log base 4 of y. That means if I divide by 2, or if I put a 1/2 in front of here, you get 1/2 log base 4 of y equals x. If x is this and x is this, that means log base 16 of y is the same as 1/2 log base 4 of y. Is there another way to get this? Certain there is. And it might be an easier explanation, but I don't know. This kind of worked out for me. It's my first time teaching pre-calculus, and since my student teaching years and years ago. I teach calculus though, so I know what you need out of pre-calculus. So there might be other ways, but boom. Now this 1/2 can be moved up. I got log base 4 of x plus log base 4 of y to the 1/2. Can multiply these two things together, log base 4 of x, y to the 1/2. There you go. And 1/2 is just a square root. All right, finally, we got some equations. Okay, this is what we build up to. I don't like these first two. They're like, just kind of like too simple, you know. I'll show you a different one over here next to this that is more important than the one you see here. Like if you have log of the same bases, obviously just like the stuff inside needs to equal. I'd rather you always think to get rid of the log base 5, you need 5 to a power. You take 5 to the power of both sides. The 5 to the log base 5 does each other. You just get x plus 1 equals 6, x equals 5. Okay. Now the same one's over here on the right, like log base 2, log base 2. Yeah, obviously x minus 3 has to equal 9. It's like makes just too much sense. But I'd rather you think, oh, I got to undo things 2 to the power, giving you x minus 3 equals 2 to the log base 2. Cancels, just 9. X equals 12. What I'd rather you do is be able to think about then solve this equation. Log base 2 of x minus 3 equals 4, like a number. Okay, and now it's not as easy as like, oh, just the insides equals the insides. You would take 2 to the power, 2 to the power. You'd get 2 to the log base 2 of x minus 3 is just x minus 3. And over here, 2 to the 4th, 16. Wait, 2, 4, 8, 16. Yes, okay. That's how I got that right side, 2, 4, 8, 16. Now when you solve this, you can get that x is equal to 19. So it's not that just like insides, it's like making sure you know you're taking a number to the power to undo the logarithm. If on one side, this number to the power ends up equaling, something else, just make sure you're ready to change that. I think the next couple are similar to that. Kind of, but not really. They're a little bit more complicated than something like this. So make sure you're like good at this. These are like the most important ones to kind of understand. It leads you to the next round. Okay, so log base 2 of x plus log base 2 of x plus 1 equals 1. I like how there's a 1 here, there's a 2. So at least we got that going. Well, this is where we use our properties to allow us to simplify this. I got x and x plus 1. I would multiply those together because I'm adding. So I'm combining logarithms. So I just have one thing. So I got x times x plus 1 is equals 1. Okay. Now, you can do this now or you can do this later. Take 2 to the power. I'm probably going to do it later because I know I'm going to need this x to be distributed. Giving me log base 2 equals x squared plus x equals 1. You could have done this distribution later, but you'll need to distribute it to solve this equation. Okay, how do I get rid of the log base 2? 2 to the power, 2 to the power, 2 to the first, just 2. X squared plus x, log 2 and 2 cancel, just x squared plus x left here. How do you solve this equation? Many of you are thinking, let's factor out an x. Let's give you this. And then you're like, 1? And that's your answer? You just like say 1? And that's actually a correct answer. But this is not how you solve this. You got to remember, if you have an x squared and an x, any version of x squared, and you're like trying to solve this equation, move everything onto one side, set it equal to 0. This is x squared plus 5x plus 6 equals 0. Why? Because now we can factor. X plus 2, x plus 3. Here, x squared plus x minus 2 equals 0. Factor. What two numbers multiply to get 6 and add to get 5? What two numbers multiply to get -2, add to get 1? I don't use this cross. Doesn't make sense to me. I more just like say, what two numbers multiply to get this and add to get that? I just put a dot and a plus there. I don't do that anymore. You guys shouldn't do that. You guys are smart enough to just be like, oh, I need x times x plus something times x plus something. What are those two numbers? +2, -1. You don't need a cross. Okay? And like just showing you, like, where does that come from? Like x times x is x squared. X times -1, -1x. 2 times x, 2x. 2 times -1, -2. Where does this number come from? 2 times -1 right there. Where does this number come from? -1 plus 2x. All right, sorry. We know this, just making sure you're reminded that. Now we get two solutions, -2 and 1. We think those are both the solutions, but turns out you're not allowed to plug in negative numbers into a logarithm. Why? What gives? Kind of goes back to the fact, like, let's think about the graph of exponential functions. Exponential functions are never 0 and never negative. They're always positive. Which means if I said, hey, solve this equation, 3 to the x equals -9. Okay, you'd be like, oh, -2, right? 3 to the -2nd is -9. Wrong. 3 to the -2nd is the same as 1 over 3 squared. It is not -3 squared. You cannot solve this equation. You might be thinking, oh, can't I just take the log base 3 of both sides? Yeah, take the log base 3 of both sides, but there's no 3 to a power that gets you -9. If you try to type this into your calculator, either using log base or change of bases, it's going to be like no error. I'll show you. No, can't. Because exponential functions are only positive. That means you can only plug in positive values, being like the whole inverse thing, x, y's, y's, x's. So -2 is what we call like an extraneous solution or something like that. Let's finish off with this guy. And then I think we have 2 more. Okay, cool. All right, I'm going to rewrite this as log base 3. I'm dividing, so I got x over x plus 1. How many of you want to take those x's and cancel? Don't do it. Okay, good question, because now I got to get rid of the log base 3. So I'm taking 3 to a power, 3 to a power. Got x over x plus 1 is left on the left side because these cancel. 3 squared is 9. How do I solve this? Let me finish this video, I'll come back. How do I solve this? Well, like, let's just like get everything on one level. How do you get everything on one level? It's x over x plus 1. Let's just multiply both sides by x plus 1, right? All of a sudden, these x plus 1s are gone. X equals 9 times x plus 1, might as well distribute 9x plus 9. Well, now I just have an equation you can solve. If you subtract x, make sure you have 0 over here. You can also just subtract 9x, you get -8x equals 9. X equals -9/8. Oh, I feel like I did something wrong because you're not allowed to plug in a negative. So then the question is there no solutions? Just making sure I did this right. X over x plus 1, we're good. 2, yep. 3 to the power, 9. Multiply both sides by x plus 1, good. 9x plus 9, that's good. left you with x on the left side. That's good. Subtract 9x, negative 8x. That's good. Divide by negative 8, negative 9/8. That's good. Try to plug in negative 9/8. That's bad. There's one really quick way that I can see if this is correct or not. We'll go into these things in the future. I'm not even going to tell you what I'm doing. When you get to calculus, you need to know how to do this. Let's not use that much. What's like an actual use of a calculator besides doing arithmetic? Yeah. There's no answer. These two lines aren't intersecting with each other ever. Second calc intersect. And it's going to be like, nope. This one looks like it's just traveling towards 0. It's going to just say no. So we'd probably want you to be able to get this. And then we'd want you to identify this as an extraneous solution. Just shows us that you know what you're doing, that you know how to combine, that you know how to take things through powers, and you know how to get that extraneous solution. That is showing me that you know what you're doing. Even though this isn't an answer and there is no answer, it's a good question to ask you to make sure I know that you know what you're doing. Okay, 2 more questions. X minus 1, x plus 1. We can combine those by multiplying. Ooh. I was thinking about moving this over by subtracting it and then combining it so that it's like this equals 0. I'm just going to leave it like this because it's going to work itself out pretty nicely. Because it's natural logs, you take e to the power of both sides, it's not that bad. I'm going to distribute this as x squared minus 1 because the minus 1x and the positive 1x cancel. E to a power, x squared minus 1 equals x plus 5. I have x squareds and x's. What do? Move everything onto one side. X squared minus x minus 6 equals 0. Factor to solve. What 2 numbers add to get negative 1 and multiply to get negative 6? That's going to be negative 3 and positive 2. Which means my solutions are negative 2 and 3. Can I plug in negative 2? No. If I plug in negative 2, I'd have the natural log of a negative number. You're not going to do that. Extraneous. Just 3 is our solution. Last one. Log. Don't like how it's logged the same way. I really want you to make sure you're doing this. That way you understand that this is 9. 2 to the first power, that's 2. Okay, like these are really easy if the bases are the same. It's when it's a number and a log. That's what's important. It's making sure this to a power, boom, then you're good. Anyways, 2x minus 21 over x plus 12 equals log x. I could subtract this over, put it all on one side and the other side equal to 0. Doesn't matter because it's the log on both sides, so we can just get rid of them by taking 10 to a power. This is going to be fun. I'm going to multiply, get everything onto one side by multiplying by the denominator here. Get rid of that. So I got 2x minus 21 equals x times x is x squared. 12 times x is 12x. Move everything on one side. I already have the x squared on this right side, so I'm going to keep it there. So I'm going to subtract the 22x and add the 21. Subtract the 2x, add 21. Give me 0 equals x squared plus 10x plus 21. 2 numbers that add to get 10, multiply to get 21 are 7 and 3. Meaning my solutions are negative 7 and negative 3. Now, negative 7, negative 3, you can't plug in either of those. You need to be able to get those solutions and identify that there's no solutions. Probably would ask you a question on the quiz, like what are the extraneous solutions? That's a way to make sure I know you know what you're doing. But that's it. That's the homework. Hopefully this made sense to you. And onward and up.